Welcome to part 2 of the A310 video series we're doing. We're currently located on stand 62 at Prague International Airport. The airport is located quite close to the city itself. Consists of two main runways, runway 24 and runway 30. A nice little detail that's included in this scenery is the fact that the Maxes have been parked there for I think nearly 2 years now, and you actually can see them in the scenery over there. But why are we here, and what exact airframe are we in? Well, we are in the Czech Airlines A310. This A310 is the Pratt & Whitney equipped variant. As the first video we went with the General Electrics. But what is this video going to be focused around? We're going to focus on failures, how to add them, how to remove them, and a bit more in-depth look at the A310 systems. So what do we have coming up for you in today's video? We're going to have failures, how to add, remove, and how to sort of manage the system inside the A310. Then we're going to talk about a bit more in depth about some of the system changes and additions that have been added to the A310. This will get a little bit more technical, but that's what today's video is for. Then we're going to look at some basic failures on the ground, trigger them, see what consequences they have, and have a look at the ECAMS that come up. Then we're going to move on to a little bit more complex failures, mainly focusing on the ground still to keep it as a learning environment. And then we're going to move on to engine failures. We're going to talk about how you deal with an engine failure, how the aircraft responds to an engine failure, and then we will fly an engine failure at the end, as today's flight will be a simulated flight from Prague to JFK, which this aircraft actually used to operate. So without further ado, let's get into the failure system. Okay, welcome to the flight deck. We've got the aircraft set up, we've got the ground power on, and the route is in for our flight to JFK. So what we're going to focus on straight away is how the failure system works. How do we add, remove, and also what failures are there. So let's take a look at that now. Okay, so on the FMS, you want to click the menu button. You'll be brought up with a menu failures, add a failure, and now we're given the list of failures. So let's just take a quick overview of what we have. We've got engine fires, some APU and hydraulic faults, more servo faults, some basic faults there, anti-ice, pitch trim, yaw damper, rudder travel, individual spoiler faults. We have flap system faults, so the flap system 1 and 2 when they're together gives you flaps jammed or slats jammed, so you can do them independently, or you can do flaps and slats jammed, which is really quite cool. You have an engine 1 failure, which is obviously slightly different to the fire. Generator failures, so more of the electrical stuff, dual AC bus failure, some PTU failures. We have a cargo compartment fire, and we have some leaks, so when you're high altitude you get a depressurization from different areas. The slat failures we talked about before, some more electrical failures with AC bus 1, AC bus 2, standby gen failure. We'll get to what the standby gen is at some point, I'm sure, in this series. Cabin pressure failures, so pressure system controllers and the flaps and slats jammed. This is the center of gravity control computer failure, so if that fails you will be presented with an ECAM to try and rectify what's gone on with it. It just doesn't stop working, but has associated isolation valves. These are the fuel valves on the overhead that basically isolate the whole section of the fuel system, so you can fail and close those. And then finally pack 1 and pack 2 failure. So I went through those quite quickly because I think you can see there is a lot that you can choose from, and a lot of them are quite serious failures, and a lot of them are obviously quite in-depth. So we said we're going to see how do we add a failure. So let's add something simple and start at the top of the list. Okay, let's add an ATS-1 failure. There isn't much associated with this, but let's see. So we click it, and you can see at the top it now says not active, so obviously this means that the failure is not currently being triggered. You can choose for seconds after takeoff, feet after takeoff, above speed, and then it will become active. So we're sitting here on the stand and we're 1300 feet up, so one easy way to actually trigger something on stand is to put 0 feet after takeoff, and obviously we're above 0 feet, or you can do 0 seconds after takeoff, because obviously that would be right now. So we're going to choose 0 seconds after takeoff. Now you can see that this has gone to active, and we just heard the little click on the overhead, so let's have a look. So as we can see, the ATS is now triggered off. If I try and trigger on, it will delatch as the system has failed. Fairly simple, but that's really how you add every single failure. Let's go and have a look again. So let's say that we were finished with this failure and we want to clear it. So we click clear, ATS 1, and now the failure is not active anymore. So let's try and trick that ATS back on. Okay, so let's try it now. And it stays latched because the system has no longer failed. Okay, so as you can see, not that complicated of a system. Yes, you can have multiple failures, so you can have them stacked, and they will show on this page here as active, and you can clear as many or keep as many as you want. But really, that is how you add and remove failure on the A310 and what failures we have. So let's move on. Okay, in this next section, we're going to focus on the system changes that have gone on with the 310. Now, honestly, if I had to cover everything that we've changed / improved, I would be here for hours and hours, because we have touched and changed virtually every single part of the aircraft. Some of it more major than others, but we're going to try and pick and highlight some of those areas. Honestly, the ones that I can remember. I am sure there are things that I will forget or not run out or not have enough time to show that you may come across when you're flying the aircraft. But let's take a look at the overhead and start from there. Okay, so you join me looking at the overhead. So we're going to go through the overhead from left to right, talking about the system improvements and also which part of these fail. So when you have an associated failure in the FMS that you add, where will you expect to see the fault light and what will be the impact of that failure? I obviously can't remember all of them. I'm going to do my best and we'll try and go through as many as we can. So let's start on the top left, the hydraulic system panel, which is located here. This is the whole hydraulic system. So you've got the individual spoilers. I think it makes sense that you can just turn them off with a fault. So when they're at fault, they obviously no longer work and you get an associated ECAM. That's about it. Rudder travel limiter is an interesting fault. So if you fail both of the systems, then you have no rudder travel limiter, and you'll get an ECAM. Now we're going to talk about ECAM, what it is later on. If you're not sure what an ECAM is, maybe fast forward and come back to this point. So you'll get a procedure that actually tells you to refer to the QRH. The QRH is the Quick Reference Handbook. It's effectively a big paper manual that comes with every airliner that's made by the manufacturer that gives you different procedures to apply. But a lot of those are electronic on the screen in the A310. But anyway, what does this fault mean? It means that when you are above 170 knots, I believe, you need to be very, very, very careful with using the rudder because there's no limit to how far it can move. Now this is especially important with the A310 and the A300 family because there was an extremely tragic accident with an American Airlines A300 where they took off and they encountered wind shear, and the first officer overreacted with the rudder and cycled them back and forth and back, and that actually snapped the fin of the aircraft clean off, and the aircraft crashed and everyone on board was lost, and even a few people on the ground were as well. So that's why they fitted the stop rudder input light that we've talked about in the A300 training. That's still present on the A310 due to that accident, so they're all retrofits. But anyway, the rudder travel system fault means it's even more important because above a certain airspeed, the amount of movement is limited slowly but surely the faster that you go to try and reduce that, but that system just doesn't work at all. And in the sim, the fin won't break off, but it will be extremely violent if you move the rudder a lot at high speed. So it's quite a cool failure. Below that we have the servo controls, and you can fail these. So what they do is you have one for each system, so one for the blue on the left, one for the green in the middle, and one for the yellow on the right. So if you fail them, the hydraulic system still works, but the flight controls associated with them no longer operate. So if you fail the green system servo, all of the flight controls associated with the green system no longer work. But the actual green system itself is still operating. So you can put the gear up and down, your nose wheel steering will work and all that sort of stuff. Moving down, you have the green system electrical pumps. See, pumps, not pump, It's 2 pumps, 1 switch. You can fail that, and you can also fail the PTUs, which are the power transfer units. These transfer hydraulic pressure from one system to the other in case of a hydraulic fault or even an engine failure, but we'll get to that. So here we are with the electrical system. Now what's changed here? Quite a few changes to bring in line with the failures that we can have. So as you remember, we can have AC bus 1 failure, AC bus 2 failure, and a few other electrical failures, including standby gen faults. What does this all mean? Alright, so the AC buses are basically almost like where a lot of things are connected to. If you had, for example, a power plug plugged in the wall and you had 8 or 9 other devices plugged into them, if you lose the AC bus, it's like pulling the main plug out, so and then everything else attached to it just goes ugh and stops working. It's a pretty crude explanation, but it's basically what they do. So when you lose one of the AC buses, you lose a lot of systems. So we're not going to look at how you deal with the failure now, but we're going to look at what that failure does to us in this current situation. So let's fail AC bus 1. Okay, here you can see we've got an AC bus 1 failure. Not too dramatic. The left ECAM no longer works, so this screen here. We've lost some engine indications and their analog backup. But we don't really need them too much in flight, so it's not that big of a deal. Let's take a look at the overhead. On the overhead you can see AC bus 1 is shown. We've got some fault lights in the fuel system, some window heats, and also the one that's quite a big impact to the flight is ADS 1 and 2 will no longer trip on. So as you can see, the auto thrust is completely inop. We're going to do the same for AC bus 2, so we're going to end up with a dual AC bus failure. And then we're going to talk about the standby gen. Okay, things have suddenly become quite quiet in here. So now we've got a dual AC bus failure. And we are left with the PFD and really not a lot else. We've obviously got the analog standbys that all function. A lot of the engine indication is lost. All of these screens are lost, and both our FMSs is lost. And also the FCU is blank at the moment. That's because the engines aren't running. Obviously if you had this in flight they would be running and it would be powered. So let's take a look at the overhead. You can actually see now that the overhead looks a little bit less severe, but that's actually false because a lot of these were wired up to the AC bus 2, so the failure is so severe you can't even see the lights anymore. But as you can see, AC bus 1 off, AC bus 2 off, AC essential bus off, AC essential on BAT now, and the AC emergency on inverter. So basically the aircraft is running off the batteries of the aircraft, which is really not good, and we have lost a significant amount of the systems now. So obviously these are no longer going to work. A lot of things have tripped off, and in flight this is not a good situation. Okay, so we've now got both engines running. Now this is just for a demonstration of the standby generator, so let's take a look at the overhead. Okay, so let's talk about this standby gen. It's a guarded switch here with a position that normally says auto, and it has quite a few trigger conditions, but basically in flight it will automatically turn on, and on the ground you need to manually put it on. And when you manually put it on, it only lasts for 2 minutes and then it turns itself off. So let's try and turn that on now. So we've turned that on and we can see we've got override, and you can see we get a lot of systems back, like a lot of fault lights start showing up, which is good, and you can also hear the ECAM or the FWC made a noise, and you can see that some of these lights aren't illuminated anymore. This will only last for 2 minutes and then it will turn off because it's basically just running a self-test. So now we're taking a look down here, we can see that I've recovered the FMS, the ND, and a few other things have come back as well. But I know I've gone quite in depth with this failure, but I wanted to do that to basically try and show you the standard that we've gone to with these failures. For the rest of them, we're just going to sort of quickly talk about it and move on. Okay, to quickly finish off the electrical panel, you can have IDG faults, generator faults, and they'll obviously lead to different scenarios, different situations, but generally makes sense what will happen with those. The pitch trim, you can have faults on these and the yaw damper. If the yaw damper does actually, both of them fail, you will actually feel it in manual flight. The yaw damper is properly disabled and you can really feel that the aircraft kind of slips a bit more. With pitch trim 1 and 2 off in flight, it's actually a really complicated, long procedure, quite a long ECAM, because it basically means that you've got limited pitch control, so you can't go too fast, you can't go too slow, sort of things like that. But you'll see it on the ECAM if you decide to do a pitch trim 1+2, but in flight. On the ground, that ECAM is inhibited, so different ECAMs have different phases. Some of them show in the air only, some of them show on the ground, some of them show after engine start, so don't expect to press fail and always see an ECAM for something. ATS 1 and 2, we've talked about just auto thrust. If you fail one, nothing happens. If you fail both, you lose the auto thrust system and also low speed protection. Anti-ice, you can fail the anti-ice and then you'll have to use the alternate mode. It's actually kind of cool that the aircraft even has an alternate mode, but I believe it stays, no, then it becomes functional. That's correct. Lights, nothing happens there. With the fuel system, you can fail the isolation valves. So these are the isolation valves here. They actually work fairly similar to the servo control valves. So if you press them off, then that whole section below it is cut off. So in this case, any fuel in the outer tank, if this was off or failed, would not be accessible. Same for the isolation valve on the inner tank. But be warned, if you, for example, had engine 1 running and you fail both left isolation valves now, your engine will flame out as it has access to no fuel, because the crossfeed is closed by default. If you then open the crossfeed and failed these, then the engine will feed from this tank and this tank, etc, etc. Same for the APU, it will flame out if it doesn't have access, so be careful when you fail these isolation valves. If you're just messing around with them in flight, it can have bad consequences. The other one on the fuel system is the trim tank fault. So if you have a CGCC fault, the CGCC will fail to operate, so it will no longer target the correct center of gravity throughout flight. It will no longer move the fuel around, and you're given an ECAM to try and pump the fuel forward into the center tank. But be careful, because you can overfill the center tank, or you can kind of it warns in the FCOM that it's possible to spill, but obviously in the simulation here you can't spill fuel. But again, it's a good practice to not just dump the fuel in. Moving to the top of the overhead panel, we've got the fires. So you can have an engine 1 fire, an engine 2 fire, and an APU fire. Cool enough is when you have an APU fire on the ground, it acts differently to an APU fire in the air. So if we have an APU fire on the ground, the aircraft, very smart for the 80s, will shut itself down, will shut the APU down, I should say correctly, and will also then automatically fire the fire extinguisher. So the agent will discharge itself. In the air, it tells you to discharge the agent. So it does this because you can leave the flight deck unattended. So in some aircraft, when the APU is running, a pilot always must remain in the flight deck, because if you have a fire with the APU, you need to take action. In the A300 and A310, this is not the case, because it will do it all for you if it's on the ground. Nice feature. But the fires, they run as you would expect. You get an ECAM, follow the ECAM, and normally when you discharge both the agents, the fire will go out. That's generally how it works. Cargo fire, you can get a cargo compartment fire, and then you must use this selector here to basically unguard the switch. Use either agent 1 or agent 2, or agent 2 then agent 1. This fire won't always go out, kind of a cool one, depending on the order of which you do in the extinguishers, because it leaves one of those scenarios where it's an unextinguished fire, so you must land immediately. It's kind of a cool failure. Pressurization system, you can have a regulator 1+2 fault. This means that you must take completely manual control of the pressurization system. This is all modeled. Basically, if I just turn these off now, you can see you get the arrow that points to here, and when I turn this on, I am now manually moving the outflow valves, which you can see here now, and that's effectively what you will have to do if you have a regulator 1 and 2 failure. You would have to take control completely yourself. Actually quite an involved fault and involved failure. Takes a lot of fine tuning to get it right, but a cool one to do. For the bleed system, you can have a pack 1 or pack 2 fault, or pack 1+2 fault. Pack 1+2 fault is kind of interesting because you will slowly start to depressurize, not as quickly as you would think. That's actually fully modeled. You will lose about 300 to 400 feet per minute initially, but obviously this will continue to get worse if you continue to climb. because there's no more pressurized air coming into the cabin. But an aircraft can hold air quite well. If you think about it, it's only leaking out of the little gaps in the doors and things like this, but eventually it will depressurize, so you will need to descend, and then you'll have to manage that all yourself, so you can add those failures in. Okay, so we'll talk about the flight control failures that we can have now. Technically it is a hydraulic failure, the flaps and slats system fault, but it will lead you to not having either flaps or slats. It's a very involved procedure, and the handling of the aircraft can be quite difficult. Weird pitch attitudes on final approach, very high approach speeds, sometimes 170 odd knots if not more, but a really cool one to do. And X-Plane does an excellent job of simulating sort of partial flaps, partial slats. It's very, very good at that. Okay, that about covers it for this section of the failures. This was just a run through of what we have and where they're located. I think you can see that we have a nice selection of failures throughout all the different systems: electrical, hydraulic, pneumatic. I didn't talk about all of them. We're going to practice some of the ones that I didn't talk about later on, but let's get on to the rest of the video. Okay, let's move on to some of the systems improvements that you're going to see, not just failures. So one of them that I really do like is we have a completely custom EGT system now. So we've got a lot more data for both engine types, and it's actually a completely custom system that allows us to do some pretty cool things. So for starting, you're going to see a lot more accurate EGTs in flight, cruise, even with engine fires. There really will be a lot more accurate, and there's a lot more variance between the GE and the PW now. Now this system has allowed us to also refine the engine starts. So engine starts are a bit more realistic, times were just adjusted a little bit, and also they are slightly different on the A310's engines, but we were just mainly able to get a bit better data. But one thing that you can do on the A300 and A310 family, as opposed to later Airbus aircraft, is you can actually mismanage the starts. What do I mean by mismanage it? Well, with the later aircraft, they are fully FADEC equipped, and it's a full auto start. It's not an automatic start in the A310, but it does have a FADEC. Now, what is a FADEC? It's basically a computer that controls the engine start, or controls some elements of the engine start and the engine itself. But what we can do is, if we introduce fuel during the start procedure a bit too early or massively too early, then the engine will what's called hot start. So basically it's just going to get way too hot way too quickly because you've introduced the fuel and it just wasn't ready for it, and your EGT, so your temperature in the exhaust gas temperature, is going to go through the roof, and that's an indication that your engine is extremely unhappy with the situation. So why don't we try an engine start? We'll do one where we hot start it and one where we do it normal. Alright, let's put our beacon light on to let them know, the ground crew, that we're going to be starting an engine. Let's put the ignition to Bravo. We're going to be starting engine number 2 first, so we're going to open the start valve and let's look down. So we can see that the N2 is there. We're going to now introduce the fuel at 8% N1, which is far too early. EGT already is rising. It's getting quite high already. Hot start limit is about 525 degrees Celsius, and it would recommend now that we would abort the start. So okay, so abort the start. Okay, EGT dipping. We're slowing down. Okay, and we save the engine. So in the QRH, it recommends that if you see EGT over 300 degrees Celsius below 30% N2, abort the start. So what you can see here is the EGT is quite warm, and it's actually still cooling down because obviously we got the engine hot and now we've cut the fuel off and we're letting it come down. It will retain this heat over a certain period of time based on a fair few factors. So you will see after a long turnaround, for example, you may try and start your engine and they're still at 80-90 degrees Celsius. That's normal because they're holding the correct amount of heat now. And you can see that the other engine is at 24 degrees Celsius. We have an ambient of 16, so a bit above ambient makes sense. Okay, let's try that again, but let's start engine number 1 and do a normal start. So we move up to the overhead, igniter to alpha, open the start valve. We have the open light. We can now see we have N2 rotation. We have some oil pressure, so you can see we now have a custom oil pressure system, so we get basically a little bit of oil pressure as the engine is rotating before the start, which is now correct. So we're waiting till we're above 20% N2, which is about now. So let's put the fuel in. Fuel is introduced. We have light off. N2 is slowly rising still. N1 is now just starting to rise. We have the low oil pressure light on here, which is correct for the Pratt & Whitneys. This stays on till around 70 psi, which is kind of a long time. You have this low oil pressure light on. If you start the GEs, it goes away almost immediately. Now, as you can see, look how slow this EGT is rising compared to when we did the hot start. You can see that it's very much just this slow, progressive build in the Pratt & Whitney. Honestly, I'm very surprised with how slow this engine start is, but it shows you the different characteristics of the engine. It takes around 2 minutes for this engine to successfully start. The next thing we're going to expect is at 45% N2, we'll hear the starter valve disengage, which we heard now. We saw the bleed pressure drop on the engine page here. Next thing we're going to see is at 52% N2, the generators will kick over, so it's going to actually kick on and we'll get the flash on the screen. This isn't any different from the A300, but the whole start process is now just a bit more refined. And there we go, it kicked on at 50%. Engine's almost stable now. And peak EGT, so the EGT is already starting to come down. And that looks like a good engine start. So that was a good engine start. Now what we're going to do is we're going to do the same thing again, but in the GEs. Okay, so here we are in a GE equipped aircraft. Now we're going to start engine number 1, same procedure. So let's have a look at the overhead. We'll use igniter alpha. Open, have the open light. Let's look down. N2's rising. Again, a bit of oil pressure. You can see the scales are a bit different here now, so it goes from 0 to 100, not 0 to 400. This was the same in the A300. Gotta wait till we get over 20% N2 again, so we're over 20% now. Let's introduce the fuel, and boom, we get light off. Now you'll notice that the EGT rises quite a lot quicker and is quite a lot higher at its peak EGT. And also you will notice that the engine start is significantly quicker. So you can see the low oil pressure light went off almost immediately as I introduced fuel. And you can see that the limits for the EGT are all the way around here at 960 rather than that. So there's the starters already cut off. Almost getting up to peak. So it's around 568 was our peak EGT, which is not too bad. That's a normal engine start, but for the PW would be a hot start. So shows you the difference between these engines. And there we go, the engine is already started. So it's a lot quicker to start in GE, just the design of the engines and how they are. But thought I'd show you that because it's kind of cool to see the different systems across the different engines. Okay, so what other system improvements have been made? Now these are simply going to be a few that I've picked out. As I've mentioned before, if I tried to go through all of them, I'd be here all day. Now in the FMS, you can actually now do step climbs, step descents. Okay, we're going to quickly talk about step climbs because I think it's worthy of a demonstration. So there are a few restrictions to the step climb system in the A310. Number one, you can only put one step climb in. Now this is how the real aircraft works. So if you're in the cruise or you're on the ground and you want to put a step in, you can put it in at any waypoint in the flight plan, but you can only put one, which is, I know it's a limit, but that's what the real aircraft can do. The other one is, so in this example, we're climbing up to flight level 340, and then later in our flight, we want to step up to flight level 360. Now let's try and enter that now. So let's say that we want to climb at Oscar Kilo Golf to flight level 360. So we line select on the right hand side, we click on step prediction, we click step to flight level 360, we enter it, and then we click insert, and we can see that the flight plan updates and we have 360 shown there. Now what we can't do is we cannot raise our FCU altitude up to 360 now and expect the aircraft to level off and then step climb up, because if you remember all the way back to the A300 videos, the A300 and A310 have no VNAV in the climb. So it will just climb all the way up to flight level 360, completely removing the whole point of the step climb. So what I'm going to do is we're going to level off at flight level 340, and then I'm going to show you how the automatic step climb works. Okay, so here we are leveling at flight level 340 with our step climb to flight level 360 at Oscar Kilo Golf. So we're level now, P-speed, P-alt. So now what we do is we wind the altitude up in the FCU window. Okay, so we can see the arrow here shown on the ND, and what will happen is 30 seconds before we get to Oscar Kilo Golf, we will flash P climb below P alt. It will engage and it will climb up to flight level 360. Now obviously in your actual flight, this sort of step climb will happen hours into the flight, so your best way to do it is to climb, level off at your initial cruise altitude, put your step altitude that you want to do in. Remember, you can only do one. Wind the FCU altitude up and go away, and that's it. And you should come back and it will have automatically done the one step. Now, some things to be aware of. If you wind the altitude down again, so if we brought this altitude down to flight level 340, we will get a message in the FCU. We will get a message in the FMS that says flight step removed, and it will remove the step climb because that's how the system works. One final thing, we have the immediate climb function. So what you can do is if you think, no, I don't actually want to wait until the waypoint, you click immediate climb and it will climb immediately to the flight level that's set in the FCU. So we can see that P climb is flashing, so within this 30 seconds we should start to automatically climb. Okay, P thrust, P climb, new cruise is flight level 360, and the aircraft will climb up to the new cruise altitude. Step descents, you can do step descents, they work exactly the same way. So B level, put the descent that you want in, set the altitude down, and when you come back it will have done the step descent. Now I hope that's a quick overview, but I think that covers basically everything that you need to do with the cruise, altitude and the step climbs. We have the nav code come across from the Beluga, which was made specifically with the A310 in mind. Gives you a lot more sort of confidence, a lot more accuracy in the turns and the way it rolls in and rolls out of turns. So really, really nice that that's in there. Brand new flight model using the experimental flight model. Not many airliners in X-Plane actually do use the experimental flight model, but it's a nice step up in terms of flight modeling. We also have the custom ground handling, which basically means, well, there's custom ground handling in terms of the equipment, and there's also physics, like how it handles on the ground. So if you are heavy and you release the parking brake, which we'll do now, you can see that we don't roll at all, and the aircraft will need a bit of power to get rolling, and then once you're rolling, you can roll at idle. If you are quite light, it will roll at idle. Now that's how the real aircraft works, in fact how most transport aircraft do actually work, especially Airbuses. But that's all modelled here in the 310 and even been refined over what we had in the A300. I'm going to stop there because there's so many that I will be here forever and ever. So let's move on to ECAMS, what they are, how we're going to do them, and also a slightly more complex failure, but that will be done on the ground. Okay, so what is an ECAM? An ECAM stands for Electronic Centralized Aircraft Monitoring. And basically it's an electronic version of the QRH, that big manual we talked about earlier that has all of the procedures that you need to do when you have a failure. And what's very smart about the A310 is it knows what failure just happened, and it will give you that procedure on the left hand screen shown here for you to do. So you don't have to go and get the QRH. Sometimes you do, because not all of them are on the screen, but for all the major failures there is normally an ECAM associated with it. Now let's add in a green hydraulic failure and see how this presents. Okay, so I've made the screen quite a bit bigger so you can read what's going on. So you can see that the master caution has come up in amber. Now you can clear that. The first pilot that sees that can clear it and call out master caution. Now you can see we've been given hydraulic, brake, anti-skid, alternate on. Now that line is already in white, because if I move this, can you see I already had it in place? To show you, it goes from blue to white. So white means you have completed the item and it's in the position that I expect. Not every single item on an ECAM is what they call monitored, so it won't change from blue to white, but nearly all of them will. So the next line we have green system low pressure. Now that makes sense. We look at the right hand screen and it's brought up the hydraulic information page, and you can see, if we make that bigger, that yes, indeed there is no pressure in the system, which makes sense. So we'd work through all of these different ones if we were doing this procedure properly, and then what we would do is we would need to clear the ECAM screen. Now how do we do that? Okay, we do that using this small panel here called the ECAM control panel. Now you can see that the clear light is illuminated and the hydraulic light is illuminated. So it's showing the hydraulic page, and if we want to clear the hydraulic, we clear that, we clear that, and we clear the next one. And eventually when you've cleared them all, it brings up the status page. You can get to the status page at any time by pressing the status button, but at the end of an ECAM procedure, it takes you there automatically. Why is that? It's so you can review the state of your aircraft. So, status, makes sense, right? So you can see that the landing distance, we've got something wrong there, a few procedures that we need to run, one of them being quite important, that the gear will no longer come down by itself. So if we were in the air with the gear up, we would need to run the gravity gear extension procedure. That's not going to come up on the ECAM. That's why it's telling you, hey, you actually need to go and look for this procedure. That's why it says it. And you can see it's telling us the nose wheel steering doesn't work, the auto brakes don't work, and the green servo is not working, which makes sense. Slats are slow and flaps are slow because of the hydraulic. Cool. So let's remove the status. Sorry, let's clear the status. And it then brings us back to the main page with the little status on the top right to show us that there are things on the status page that we need to be aware of. That's really how you deal with a failure, and this is the cool thing. Every single failure is dealt with the same. Hydraulic, a anti-ice failure, auto thrust failure, an engine failure, they're all presented and run in exactly the same way. We're going to be doing that at the end of today's video with the engine failure. And like I said, anytime you think, well, what is the impact on the flight? Bring up the status page. Okay, I'm finished with that. Then you can think, well, what failures did we have again? You can hold the recall button and it will show you that we had the green system low pressure. You let go and it goes away. That's a very quick run through of the ECAM system. Next, what we're going to move on to is talking about the engine. So I've done this a little bit differently. This is actually me flying, but post-commentary me after the fact, because it turns out that flying using a joystick, microphone, camera is too much. So I flew it and now I'm talking over the top of it. So what are we expecting? I'm going to check the approach just to see if everything's clear. It looks good to me. We are going to be going down the runway. The engine's going to fail at around about 160 odd knots, so just below V1, but within the margin that we need to continue. We're going to put a lot of rudder in. You need a lot with this aircraft, just to the powerful engines and also the fact that we have kind of a shorter fuselage, so the rudder doesn't do as much. But what I'm going to do is going to be a little bit quieter now for the takeoff roll, and once we're up in the air with the gear up, I'll start saying what I'm doing again. Thrust is set, and I'm holding the yoke forward to release at 80 knots to be released by 100 knots, which you can see we're doing now. Okay, we've got the engine failure, slow rotation up to around about 12.5 degrees. As you can see, that's sitting there. Flight directors might not be correct, it's not like the 320. You have to kind of rely on the pitch attitude. You can hear me trimming. I'm now already starting to use the rudder trim, which I have associated to 2 keys on my joystick. As you can see, it's a little bit movement all over the place, but that's because, you know, trimming in the sim can be quite difficult. Now, next thing we have to try and make sure we do is don't follow the flight director, because if you can see it's gone into nav and our course was to the left, so we need to pull heading. So I will select heading, which I do now, and I set my present heading. Now we're good, so we're in trim, engage the autopilot. As you can see, the aircraft moves a bit, so it does seem quite violent when you engage and disengage. Now, what I'm working through now is I'm working through the ECAMS. So the first line on the ECAMS says condition ignition to continuous, which I've done, and I'm going to move thrust lever 2 to idle, which I've done as well, and the next line item says turn off the engine if no immediate relight, which we don't have. So now we're climbing away, we're sort of secure, so we're going to clean the aircraft up, put the gear to neutral, disarm this, and we are waiting till we get to our 1,500 feet above ground level, which is around about 2,600 feet, and then we click Alt Hold. Now when we click Alt Hold, like I did now, can you see the speed automatically went to that preset speed? That's why we preset the speed. 250 knots, so the thrust stays on, we're still at toga, and now what we're doing is we're leveling off to accelerate, and we're retracting the flap, so one setting of flap has come up, and then the next setting of flap is going to come up, and then we are going to set an altitude higher than our current altitude so that we can keep climbing up because we don't want to level off here. So here we go, I set it up to 5,000-6,000, that keeps us nice and safe. Now if you were in flex, you must select toga manually on the TRP. I was already in toga, so that's why I left it there. So now we're going flap 0. Now what happens, which is very, very strange, is the aircraft gives us back control of the rudder. Now what I mean by that is the rudder trim is reset to 0 over the course of about 10 seconds. So now I click level change while I'm approaching the green dot, and I'm going to manually set MCT on the TRP. But you will see the aircraft start to yaw in a moment, and I just confirmed the engine out on the FMS there. So you can see it kind of in about a few seconds where it starts to kind of yaw, see here now. So basically it's resetting the rudder trim to 0, and now we have manual control, so you must use your rudder pedals to take control, and now I'm showing you how you would manually control the rudder trim here by adding it in. You can obviously use those keybinds that I used earlier. Now reasonably in trim now, and we're climbing away. Now, one thing that you saw me do was confirm engine out. Now, the aircraft will automatically detect when there is an engine out, and you have to tell it on the FMS, yes, I do confirm there is an engine out. If it doesn't detect it, there's a button on the FMS called engine out. If you press the engine out button, it will then say, please confirm that you have an engine out, and thus the FMS will go, okay, there was an engine failure, good. Now, I'm working through the rest of the ECAM, and it's stating that we need to try and turn all these hydraulic systems on because they failed. So what we can do is turn the green pump on and turn the PTU on. Now this will power up the system we lost with the associated engine. This is a real procedure. It doesn't tell you to do it on the ECAM, but it will clear a lot of the ECAM up. That's what they do in the real aircraft. As you can see, the aircraft flies quite nicely in heading select, so it's reasonably docile now. We just need to keep an eye on, obviously making sure that we have the right amount of rudder trim in, and I'm popping the ECAM up now so you can kind of see it's telling us, okay, the pack 2 is not working because of the engine 2, so we turn it off. It's saying please try and reset this, so I'm trying to reset it, and it goes, yep, that's worked, and please turn off that, the elec, because the Gen 2, and I think, right, okay, I'm going to start the APU to get that back. And you can see there's kind of a lot of mess on here now, so I start clearing it out, clearing the elec, clearing the hydraulic issues, clearing the air issues, clearing the other one, and then we go to the status page, which shows that we are procedural single engine operations, our generator 2 doesn't work, and our APU. Now, if we didn't power up that hydraulic system by using the PTUs, remember they're manual in this aircraft, not automatic like the A320, then we end up with a very different looking status page. As you can see, look, we have a complete hydraulic failure, so we have all these different procedures to try and run through, and if we turn it back on, then it changes, and you can see it dynamically recompiling back as it would show us before. Well, that was about it. I had to run through that very quickly. I know there's a lot to take on. I recommend watching it back again, but the point of this video is to kind of show off that this is there, ready for you to be used, not a tutorial on how to do engine failures, because that would be a 30-40 minutes video completely on its own. So let's take a look at some more of the cool things that we have in. Okay, so I thought I'd end today's video on a fun little point about the A310, and it's the performance. The takeoff and climb performance of the A310 is astronomical, and I really, really mean that. its engines are far too big, as we talked about in the first video, and it has far too much thrust when operating with two engines. Single engine, as you saw, it climbs okay, but I wouldn't call it overpowered. But what we're going to do is we're currently at a weight of 89, so 90 tons, which is 10 tons over the minimum weight, which is about the minimum complete empty weight of an A300. We're going to take off in toga, we're going to climb, and then we're going to leave it in toga a bit longer than we should do, just to show you this climb rate. Manually going to fly this because the flight directors are not going to be able to cope, because they can only pitch up to 70.5 degrees, and we're going to need to pitch way more than that. Now, before you say that's ludicrous, the real aircraft would not be able to do this, we have data that shows that when this aircraft is at this weight, you will see peak climb rates of 8,000 feet per minute. That's right, 8,000, which is mind-blowing for an airliner. This truly was the era of, well, that engine's big enough and it has enough thrust, so that'll do, and they just stuck it on, which makes this aircraft just unbelievable to fly when light. And actually a lot of 310 pilots say that it's not pleasant. It's actually too much. The aircraft can get out of control, so you have to be very cautious. But let's see what they're talking about, because it really is a thing to behold. Okay, park and brake off, stabilize the thrust. Okay, thrust SRS runway. Hold the nose down, definitely going to need this for this takeoff. Okay, you can really feel the power kicking in now. Thrust is set, 80 knots, 100 knots, 130, 140, 150, V1, rotate. All the way up to 25 degrees, positive climb, gear up. It's a little bit too much on the pitch. I'm going to bring the nose down, trimming nose down now. Yes, I think you're getting the idea, so let's calm this down a little bit. Level change, climb thrust. Okay, present heading select. AP1, flaps up. So, I think you might see what I mean about the climb performance. Now, we're going to let the autopilot cope with the rest of it, because it should be able to now. But, as you can see, you actually need to rotate quite quickly to stop the aircraft from over-speeding the flaps. It's something I don't think I've ever come across in an airliner before, so let's clean this up. Gear to neutral. Spoilers to disarm. And lights retract, nose light to off, and runway turn-offs off. So, we're already nearly at flight level 100. I don't know how long we've been airborne, but definitely wasn't a long time. And remember, this is a climb thrust. We're at 6,000 feet per minute, and we're still at climb thrust. Okay, let's accelerate up normally now. So let's say climb speed of 290. We're nearly at flight level 150, our target altitude. We can take continuous relight off. I've just remembered to turn continuous relight off, and we're almost at our cruise. So yeah, I don't think I need to say any more words than this is an unbelievable aircraft. You can see that we've got the failures modelled, this outstanding performance in terms of where you can take off out from anywhere. Out stars are already levelling off. You can truly take this aircraft out of small airfields, big airfields, wherever you want to go, and it's able to do it due to this insane performance. But yeah, I really hope you've enjoyed this video. We're going to end the video here, and the next video is going to be focused on the failures again, but we're going to be more flying the failures from takeoff to landing, so kind of dealing with it as you would in real time, taking a look at a few more cool things that the A310 can do. So thank you once again for watching the video, and as I said in the first one, I hope you can get your hands on the A310 really soon.